Welcome back once again to the channel. And today we have a continuation that we have to do. And today we are continuing our integers. The last time we ended with addition and subtraction of integers. Today we are going to continue with the multiplication and division of integers, how to work operations of integers, and now how to apply integers practically. That's what we are going to do today. So that will be our motive today. Today by the end of the day, we should be able, everybody here should be able to multiply and divide integers. If you want to perform operations on integers, and also we should be able to work out or apply some applications, work out some applications of integers. So this will be our motive. 3 things we are going to target today. These 3 things will be finished before our time. Good. So let's start straight away with multiplication and division of what? Of integers. We're starting with the multiplication and division of integers. Now, like I said earlier, most people think integers is a very simple topic. It's not that difficult. It's not difficult, but it's very confusing if you don't know them properly. Very important for you to know this. Why? Because as you graduate into the higher part of math, as you go into your core math, your elective math, you'll be needing some of these skills. So you have to master them well. So don't joke with them. These ones are the basics. And I've told that for you to be able to understand something better, you need to get what? The basics. So we are building basics here. If you already passed there, you have any confusion concerning integers, come back and watch this video. Good. Now, before we can multiply and divide integers, there are rules that we need to follow. There are rules that we need to do. We need to follow. Now, what are the rules of integers? When it comes to the multiplication, the rules are very simple. Now, if we have a positive number multiplying another positive number, the answer becomes positive. Take note of that. If we have a positive number multiplying another positive number, how do we know the number is positive? We've said that in the earlier video, in the first video, that the sign in front of a number belongs to the number. So when I have negative in front of 3, that means 3 is negative. But without the sign, when it's beginning the expression, it's positive. But when it's in between the expression, then it will give us maybe positive 2. So these 2 numbers are what? Positive numbers. You get the point I'm making here. If we are multiplying 2 positive numbers, we get what? We get a positive number. Let's start from here. If we have a negative number times a positive number, this gives us what? Negative. When you multiply negative by positive, you get what? Negative. When you multiply negative by a negative number, it gives you a positive number. These are the rules that we need to follow. A negative and a negative will give you positive. If you multiply a positive and a negative, that gives you what? That gives you negative once again. And if you multiply a positive, like I wrote earlier, times another positive, it gives you what? A positive. These are the rules. And the rules for multiplication is the same for division. When we come to division, the rule remains the same. That if I have negative divided by a positive number, then I'm going to get a negative answer. If I have a negative number dividing another negative number, the negatives will cancel out and I have what? I have a positive. But if I have a positive number dividing a negative number, I still have a negative. It's the same thing. So when you know this, you know that the rules are very, very important. Don't just overlook this. No, make sure you get this very, very well. Good. So these are the rules, right? In easy way, we say what? Negate, possede, negate. You understand? It's just like some small rhyme or poem. We won't say poem, we say it's a small rhyme. It's like negate, possede, negate. You understand? Negate, possede. Possede means positive, the negate means what? Negative. So possede, negate. something of that sort. You understand? Let's go through this once and for all. So once you know this, that any negative number times a positive number, that is nege posse is nege. Once you understand this, anytime you have integers and you are dividing or you are multiplying, you take note of it and don't make mistake, because when you make mistake, if your final answer is supposed to be -3 and you have a positive 3, you will not be considered. It is wrong. It's a negative 3, but you have positive 3. These and these are not the same. Keep that in memory. That is why integers is very, very important before you begin math. Those math students in Form 1, very important. And those continuing students too, if you have any challenge, most of the time you know what you're doing. But you make a mistake in your integers. So take note of that. Good. So let's go one more time. We say nege posse nege. Nege, nege, posse, posse, nege, nege, then posse, posse, posse. Very simple, right? For you to get it. You get the point I'm making here. Now, there are instances or there are certain things you need to know. In an expression, if you have A into bracket B, you see these two things means multiplication. Keep that in memory. When you see A into bracket B or a number, so say we have 4 into bracket 3. This means multiplication. So the two brackets indicate what? Multiplication. Same way, if you have 4 into bracket 3, that also means what? Multiplication. If you have into bracket 4, 3, this also means what? Multiplication. If you have 4 times 3, also means what? Multiplication. If I'm using alphabet, if you have AB, AB means A times B. When numbers are multiplying, they are very close to each other. If we have A plus B, there's that difference there. But A times B, they are what? They are very close. Take note of this. The point I'm making here is that A, B. Then we have A, B. Then we have into bracket A, B. Then we have A, B. All these things imply what? Multiplication. All these things imply multiplication. So if you are working math and you see anything close like something of this sort, they all mean we are doing what? We multiplying. Take note of that. It all means that we are doing what? We are multiplying. I hope you get what I'm saying here. Very, very, very well. Important. So with that, let's go into some workings and apply what we have said here with the rules to see if we'll be able to do some multiplication. So let's look at some examples of what? Of multiplications of integers. Some examples of multiplication of what? Integers. Let's go first. Now, if I have 5 times into bracket -3 times 4 times -2, that's into bracket -2 times into bracket -5. I'm to multiply this. No problem. Now we are going to obey the rules. This is a positive one, that's a negative number. So when a positive one multiplies a negative number, that gives me what? That gives me a negative number. So posse, nege, nege. Remember the rule. Posse is a positive number. Nege gives posse. So this is -15 times. I can also decide to multiply this and this. 4 by 2 will give me what? Will give me, this is a positive, that's a negative. Now we give -8 times what? Times a -5. Very, very important. Are we here? Are we here? Good. When we multiply a negative number with a negative number, we get a positive number. So 15 by 8 will give me positive 120 times negative what? Times -5. Are we there? I know what I'm saying. Good. I'm applying the rules. A positive number multiplies a negative and gave me negative. A positive with a negative gave me negative. This is already negative. I place it there. Now -15 times -8 gives me positive number. That's nege posse. Then the negative. So when we multiply a positive number with a negative number, I'm sure you know our answer is going to be what? A negative number. Because posse nege gives what? Nege. This gives -600. So this becomes our answer. Now I have negative, let's do division. -8 divided by what? 4. It's just as writing -8 over 4. What is -8 over 4? We have a negative number dividing a positive number. Once again, the rule says that when a negative divides a positive, the answer should be a negative number. So we have, this goes into itself how many times? Once, and go here twice. So our final answer becomes negative what? 2. Negative 2. Now, more on that. Let's look at more examples here. More on that. Now, I have 9 times negative 4, all divided by negative 6. I have 9 times negative 4, all divided by negative 6. Let me multiply the top ones. So when I multiply this, I'll get 9, 4 will give me negative. Why negative? Because 9 is a positive number, 4 is a negative. So that will give me negative 36 over negative 6. Now I have a negative number dividing another negative number. This will cancel that, and this will go into itself and goes here 6 times. So we have 6 as the answer. I am applying the rules. Working them this way feels so easy. But when you are doing your math and you are busy solving algebraic expression, you are busy doing your vectors, you have all these negatives are applied there. So you have to take note of that. The more you do this, the better you become at it. Good. So now let's also try this. We have minus 4, then minus into bracket negative what? 6, then plus into bracket. Remember I said the bracket means we are multiplying. So we take note of all that. All this divided by 9 minus 3 plus 9 minus 3 minus 2. Yeah. I have this. Good. What do we do here? Now, I said earlier that the bracket means we are multiplying. So this is a negative number. This negative, but this negative and this are multiplying. So this gives me what? This gives me negative 4. Then negative, this is like negative 1. Resemble what I said that we will have A into bracket B. A into bracket B I said is what? Is multiplying. And so if there's a negative 1 here, it looks like this. That's A outside the bracket, then this inside. A negative number times this, but the 1 is not always written there. No, we don't write the 1, but we know that there is a 1 outside here. Good. So that negative 1 multiplies this, and we get plus what? 6. Same thing. There's also a negative 1 there, but this time it's a positive 1. Positive times negative will give us negative. So this will give us negative 5 all over. Are we there? Very, very important. Now we have a positive 9. We have positive 9. We owe 3 because there's a negative in front of the 3. We owe 3, and we also owe 2. So in this, we'll have 9 minus 5. Why 9 minus 5? Because we owe 3 and we owe another 2. Good. Let's go. So here, I owe 4, but I have 6. So when I owe 4 and I have 6, and I pay, that's going to give me a 2, a positive 2, because I have more than I owe. How do I know I owe? The negative in front of the 4 tells me that I owe. But the positive here tells me that I have. What I have now is more than what I know. Only to remember that, I also owe 5. Right? Only to remember that I thought I have cleared this, but I also owe 5. No problem. I can pay. But when I pay, I'll still be owing. So this gives me 5, 9 minus 5. Let's go. So when we subtract this from this, we are going to get what? Negative 3. Why negative 3? Because the negative is in front of 5, meaning I owe. But the positive in front of this, which is not written because it's starting the expression, is what? It's positive, right? So I have 2, but I owe. When I pay my 2, I still left with 3 what? To clear. Same thing down here. Here the 9 is positive, which means I have what? 9. But I owe 5. Here I have the chest to pay because I know I have more than I do what I owe. And this will give me 4. And this becomes my final answer. So this is how we do what? We divide and multiply integers. Very, very simple. Very, very simple. So we've cleared the first one, which is what? Which is multiplication and division of what? Of integers. Good. The next time we'll look at the order of operation. When you are giving a work to do under integers, what is the order? Like we have order of fractions where we do word mass. When we are doing integers, we also need an order. And that order is what we call the PEMDAS. So now we are looking at order of operation. If we are working, how should we work? Which one should I do first? I have a question. There's multiplication, there's division. what is the order? Like you do in fraction, board mass, you do the bracket, you get the point I'm making before the off and order. So we are looking at order of operation in integers. The order of operation. And this thing confuses most people. I have seen most people getting confused when you are giving this. And the order we are going to use here is the PEMDAS. What is PEMDAS? PEMDAS basically, the P basically stands for what? Parenthesis, which is also known as what? The bracket. So bracket is also known as what? Parenthesis. So this is parenthesis. Then E is what? Exponent. If there is any exponent there, so let's say this is our what? This P stands for what? For parenthesis, or some people say the bracket. We have the bracket. Then E stands for exponent. Is there an exponent in the operation given to us? Let's tackle the exponent first. So after the parenthesis, we go to the exponent. Then M, of course, is what? Then we tackle our multiplication. We tackle multiplication. Then we go to what? We go to division. Division. Then, of course, these ones, you know them. Addition. We go to addition. Then lastly is what? Is the subtraction. Lastly is subtraction. So these are the what? These are the order to follow. This is the order to follow. Make sure anytime you are giving, we are going to follow this order to get the work. Most people get confused. Should I do the subtraction first? Should I go this one first? This is the rule. This is very simple. Follow this. PEMDAS. Like you have board mass. This is PEMDAS. We have what? Parenthesis or brackets. If there's an exponent, solve the if there's no exponent, proceed to multiplication. There's no division, go to addition. So depending, but if you have them, make sure you always do addition before you tackle anything or anything subtraction. You understand what I'm saying here? So this is the order we are going to follow to understand or to solve that. Now with this, let's go into some questions. Good. So let's go. We have 7 minus into bracket negative 5 plus 2. Then into bracket 4 minus 6. Very, very important. So we should solve this. Now we are solving this following the rules of PEMDAS. We need to work those in the parentheses first, which we said those in the bracket. So I'll come and tackle those in the bracket. Means I'm going to repeat this. Then into bracket. Now what is in the bracket? I05, that is negative in front of I05. But I have what? 2. When I pay this, I'm left with negative what? 3. Then there's brackets here. Then what? I have 4. Then we have this. This thing here means they multiply. You have negative 6. You can put a bracket here. So we should have put a bracket here. Then put a square bracket here like this to make the work easier. So this thing here, we can't put bracket and bracket in the same thing. No. So we need to introduce what we call the square bracket. So with this, I can say we have 4 plus 6 now. When I put something like this. For understanding's sake, most of the questions, they won't put this one there. But know that when you have 2 negatives like that, what it means is that this is multiplying this. The bracket, once again, we said that earlier. And you get this. So once again, we'll have minus 7 into bracket minus 3. Let's work this out now. It gives us what? 10. 4 plus 6 is obviously 10. Now, we have dealt with the parentheses. We need to go with exponent. We don't have any exponent there. So we go with what? Multiplication. We are going to multiply this with what? With that. I hope you get the point I'm making here. We are going to multiply this with this. So, but we have this negative here as well. So no problem. Let's go. That will give us what? This negative was multiplying this bracket. This negative here was multiplying this bracket. So take note of that. This will give me minus 7. This and this will give us positive. It's multiplication. So this and this will give us what? Positive. So plus 3. So plus 3. Then 10. Why am I doing that? Because this means multiplication. So I'm doing my multiplication, right? I'm doing my multiplication. So multiplication with this will give me what? It will give how long is multiplication is coming from here. So that I don't want to get confused where you go and start at the end. No. Note that this one was multiplying. So this one should have multiplied here and we get our positive. So now we'll have 7 plus 3. 3 times 10 gives us what? 30. So our final answer becomes what? 37. Very, very well. Important. Now, I have 15 divided by into bracket 6 minus what? 9. 15 divided into bracket 6 minus 9. Once again, the bracket first. So I'll get 15 divided by, in the bracket we have a positive 6 with a negative 9. That gives us negative 3. We still owe 3. Then we divide this, we get 15 over negative 3. 3 goes into itself 1. A positive number dividing a negative number, we know our final answer to be negative. 3 goes to itself 1 and going to 15 5 times. So our answer becomes negative what? 5. Very, very, very well. Important. Very important. Let's take some more questions. Let's take some more questions. Some more questions. Good. Now I have minus 11, negative 11 plus 5 plus into bracket plus 5 plus into bracket negative 4 plus what? Plus 15. Good. Now when you look at this, we have this parenthesis here, right? Which is a bracket here. But this thing means we are doing what? We are multiplying. So let's multiply this. We get negative 11 plus 5 minus 4. Why minus 4? Positive times. That will give us negative. And times negative gives negative. So this gives us what? 15. Then now we apply the rules. What are the rules? We do addition. Then we do addition before what? Subtraction. Good. So let's do our addition. Now, this is addition. That's also addition. Good. So don't go and subtract this with this. Let's add. Here I owe what? I owe 11, but I have what? 5. When I pay, because what I owe is more than what I have, I can't completely pay. So I'll still be left with something to pay, which is negative 6. Then I have minus 4 plus what? 15. Still do the what? The addition. So this will give me negative 6. Then I have 15, but I owe what? I owe 4. You get the point I'm making here. I have 15, but I owe 4. So when I pay, I'm left with a positive what? 11. Why positive 11? Because what I have is more than, this is so simple. This is so simple. You will be able to get this thing. It's more than what I owe. I have 15, I owe 4. So this will give me, now I have 11, which is more than I owe. So this one, I'll have the chest to what? To pay. Because I know when I pay, I'm still left with what? With 5 to spend. Very, very simple. Very, very simple math. Right? I hope you get this. When you get there, know the examples there for you to try. I don't want to waste much time. So, since we understand the operation, the order of operation, we are going to the last thing, which is very, very important. Here, we are now going to think and apply the integers we have done. The question will not come directly as 7 minus 6. No. We are going to put it in a word problem form. And this is what most of you don't like. But just be with me, you understand this easily. So we are going to look at the application of what? Of integers. How do we apply integers to real life? So application of what? Of integers. So practical application of integers. Practical application of what? Of integers. Practical application of integers. Now, let's go. What are we talking about here? This is the last thing we are looking here, so that the aim for the video or the aim for today's lesson is achieved. Good. When it comes to the practical application of integers, it's normally applied in finding of what? Of temperature, or finding temperature changes. Very important. It's normally applied in finding temperature what? Changes. What do you mean by temperature changes? Good. Anytime you hear, so we said application is normally done in what? In temperature changes. And this is very important. Anytime you hear a change, keep this. Anytime you hear a change, that means a difference. There has been a difference. Oh, the thing was this, there has been a difference. And anytime there's a difference, so a change means there has been a difference. And anytime there's a difference, what we do is to subtract. So difference basically means subtraction. Then change you also mean what? Subtraction. But how do I know your change? How do I know your change? Let me use this simple example or analogy here. Now, if you started out in school as a C student, right? You started as a C student, so you began. This is the start point. Let me just say the start point. You get the point I'm making here. As a C student, and you ended the school as an A student. So at the end of the day, you became an A student. There has been a change. This boy started as a C student, now he's an A student. You get the point I'm making here. How do we know the difference? We subtract your beginning from your end. Oh, in the beginning he was a C student. Now he's an A student. Oh wow! If you check the difference, this guy has really improved. The only way we will know is when we have two different portions to subtract. Without that, if you are still a C student at the end, there is no difference. C minus C goes to what? 0. You have not changed. You have not changed. But when we say change, then that means we are looking at two things. What is the change? We have to know the beginning and we have to know what? The end. So if you read any question under this, your job is to find the beginning, what we call the initial temperature, and find the final temperature. Once you get the initial temperature and the final temperature, how do you find change? You find a change by subtracting the beginning, the start point from the end point. You subtract the beginning from the end and you know the change, how far you have gone. You have to know where you are coming from and where you are now. Then you know the difference. So we are saying that most of our application goes with that. So to find the temperature change, what do we need to know? We need to know the final temperature and the what? Initial temperature. So we say temperature change or change in temperature under this. The change in temperature equals our final change or final temperature minus the initial temperature. This is how we find what? This is how we find or we do the applications. But this is not all. This one has opened us to a new chapter. What's the new chapter here? The next question is, how do I know the final temperature when I read a question? How do I tell that this value in the question is my final temperature? And how do I know that this value in my question is my initial temperature? That's the next thing the student has to know. So what are the things you need to know here? First of all, you need to know that for you to work out the application, you need to be able to know that there will be a change. Instead of applications, normally we change of what? Change in temperatures. So you need to know the change. In the change, I need to know the beginning, which we are calling the initial temperature, and the final temperature. But when I read the question, how would I know that this one here is my final temperature and this one here is my what? Initial temperature? Very important for the students to know. That notwithstanding, once you have an equation, I always tell students, those have been with me, once you have an equation, the equation has changed in temperature, final temperature and initial temperature. Don't always expect the question to give you the final and the initial. No, it's an equation. So anything you can be given this. When you are given this, then this one, if you are given this and this one, then you have to find this. Since there are 3 unknowns, the question must give you 2 of the information. The question must give you 2 information for you to be able to find the third one. Because the formula to finding it has 3 things. 1, 2, 3. So in any question, you are supposed to be given 2 informations for you to be able to find the third one. If you are given only 1, you can't find this and this. You understand what I'm saying there? In the point of giving you or the point of giving the information, they do it in 2 ways. Either you are giving directly, which every student like, or indirectly, where you have to think and get it before you do your substitution. You get the point I mean? Like I said earlier, integers, algebra, substitution, change of subject, these are the things you need. Linear equation, inequality, these are the things you need to know, and your maths will be very, very good. These topics, if you master them, the rest is just an application of all those things in different ways. All the rest. So higher maths, don't worry about that. So the question I asked earlier, how do I identify now? How do I know if the value given to me in the question is a change or is the final temperature or the initial temperature? When you read the question, you should be able to know. So when you read the question says that or it's identified as the temperature of a thermometer rises from this to that. It rises. So from The from tells you that that is your origin. So this, you know that with what? From, you read a question, the temperature rises from, somebody recorded a temperature in the morning, and the temperature in the morning was maybe 10 degrees. In the afternoon, from 10 degrees is went to, let's say, 35 degrees. The 2 tells you that we are the what? We are the final. So when you read a question, that's how you know. From, that's your initial. To, that is your what? That is your initial. So from is your final, then to, from is your initial, then to is your what? Is your final. This is how you're able to know. When you're able to know, when I put the question down, you'll be able to get it. You'll be able to get what I'm trying to say. But it's very important, not just the formula, but how do I know that this value is my initial? How do I know that this value is my what? Is my final? And how do we know if the value given to us is the change? Because like I said earlier, the question can give you the change and the final and tell you that go and find the initial temperature. You will do that. They will not always give you this and this. No, this is where the math or students begin to lose interest in it. But when you take it and listen, you understand this. Good. Now, how do we know that? In the question, you'll be told that there is a rise in temperature or decrease in temperature. This is how you know. You will not see from or to. The temperature and the temperature rises by or rose by what? 6 degrees. Oh, it rises 6 degrees. That's the change. Because there's no to, there's no from. It rises what? 6 degrees from. Then that one said that when they mention from, they are going to give you an initial. Do you get the point I'm making? Do you understand what I'm saying? Let me repeat myself again. How would I know that this value in the question is changing temperature? We are saying that you will hear this rise or decrease. The temperature rises 6 degrees or decrease by that. If it's a rise, we add it's positive. But if it's a decrease, it is what? Negative. Keep that in memory. It's all in the note. So in the question, it's identified by rise, which is what? Which is positive, and decrease, which is what? Negative. So when the question says that the temperature rises 6 degrees to or by or from, you should go to know that then this and this is what they are. So once you're able to identify, you know what changes. This is not a formula. You have to understand that when I want a change or when I want a change, it's always the final subtracted or the initial subtracted from the what? The final. And that's all you need to know. That's how you get change. That's basically. And once you know that, these things can be solved what? Easily, right? Good. So let's take 1 or 2 questions under this. And let's see how we can identify them. 1 or 2 questions under this. Good. The question says that in an experiment, I'm reading the question. In an experiment, the temperature on a thermometer drops from. In an experiment, the temperature of on a thermometer drops from. It drops from. So the from tells me that my initial temperature, because I've said that when I hear from, that's the initial. So the initial temperature equals 20 what? Degrees. Drop from. Here's the point I'm making here. To a drop from minus what? Positive 22 negative what? So 2 is the final. So my final temperature equals negative what? 24 degrees. How do I know this is my negative or that's my final? The question is 2. Now, what is the change in temperature? What is the change in what? Temperature? No problem. For change in temperature, we said the change in temperature should be equal to what? The change in temperature is the final minus the what? Initial. What's our final? Negative 24 minus what? Minus the initial, which is what? 20. Are we there? Are we there? Are you following what I'm saying here? Our final is what? It's minus 24. So the temperature, this one is negative 20. Yeah. So minus 20. Good. Yeah. The initial temperature was negative, not positive 20. Initial temperature was what? Negative 20. So the temperature dropped from negative 20 to minus 24. What is the change? Now, how do we know this? This will give us minus 24. We said this and this is now integers. Minus 24 will give us what? Plus 20. And this will give us minus 4 degrees. So the change in temperature has been what? Minus 4. How do we know it's minus 4? If this is a scale and we were on negative 20 and we drop we are dropping to negative 24. That means dropping means we go down. So decrease means we go down. So we'll have negative 21, negative 22, negative 23, negative 24. So this will be negative 24. 1, 2, 3, 4. Basically, that is what we have there. So we have dropped what? 4. And the dropping means we have dropped by 4 degrees. That drop means negative. If we rise by 4 degrees, that means we are going to count up here. 1, 2, 3, 4. That will be minus 19, minus 18, then minus what? 17. Then the last one was minus what? 16. So if the temperature had increased and not dropped, we will know. If the final temperature was negative 16 and then the thing increased by 4, but it will be a positive 4. That is all that we are doing here. I hope you understand. So I was able to identify and do that. Good. The question didn't end there. The question said that afterwards, the reading decreased by this is what I like. Afterwards, the reading decreased by what? By 8 degrees. What is the new reading? Afterwards, the reading decreased by 8 degrees. What's the new reading? Good. Our initial reading is now what? Will now be what? Will now be 24. Why? Because we have now recorded this as our final. When we move here, so if this was the scale that I was using earlier, let me just explain this. We are at negative 20. You get the point I'm making here. Then we drop somewhere to negative 24. Now we are here. There was a 4 drop. So we dropped 4 times and we're now here at negative. So now we are now in the experiment, we are now here. This is our final temperature. Then afterwards, after this has happened, the temperature decreased again by, listen, I told you. So decreased by 8 degrees means that you've been given the change. Decreased by, so that will be negative what? 8. The change has been given. That is why the question says, find the new what? Temperature. The new temperature is the final one now. So they are saying that from here, if the temperature decreased again by 8 degrees, decreased, so we'll come down. Then what will be, so that this will be our final what? Temperature. So we are coming to read the final temperature. Meaning that in the B part of the question, we've been given the initial temperature, as well as negative 24, because afterwards, after we have attained this as our final, there was a drop again to a different one. But that final one, we are supposed to go and find. But they gave us the amount of what? Drop, or the level of drop. So here the change in temperature was given in the question. How do I know the change in temperature has been given? How? Because I told that, how do I identify when there is a decrease or an increase? Then listen, he said, well, afterward, the reading decreased by, it wasn't from, but decreased by 8 degrees. So that will be a change. And because it's a decrease, we'll have what? We'll have negative what? 8. So if we want to find a new temperature, then we are going to say that, okay, we know that the change should be equal to the final temperature minus the what? Initial. And this time, our final temperature is the new temperature. What's the change? So we'll have negative 8 equals, so we're putting it here. The negative 8 is the change, equals the final temperature, we don't know, minus the initial temperature, which is what? Which is 20, negative 24. Are we okay with this? Are we okay with this? Good. So now, we'll have negative 8 equals the final. This and this will give a positive, so plus 24. We need this, so this one will cross the equal to sign. And the moment you cross the equal to sign, it becomes negative, because you've entered a new era or a new place. People don't know, you become a stranger. So this becomes this minus 24 equals the final temperature. And that will give us minus, add 6 to this, you get 30, so 32, right? Minus 32, yeah, minus 32 degrees. So this will be the final temperature. If we are here, and it dropped 8 degrees, and there was an 8 degree decrease, that means when we start counting, negative 25, negative 26, negative 27, negative 28, negative 29, negative 30, negative 31, negative 32. That is 1, 2, 3, 4, 5, 6, 7, 8. It has dropped. and you could see that our final is now minus or 32. Practically, we use this scale. Then when we do calculations, we also get that. This is all we are talking about here. The most important thing for you, the student, is for you to be able to identify and understand what I'm saying. In the second question, once again, we were told that what? That the change was this. We're given the change. So we have to go and find the what? The new temperature. Now, there are a lot of questions here that you have to solve by yourself. You get the point. And when you are solving and you have any challenge, you are free to go into the comment section and ask your question. You get the point I'm making. Go into the comment section and ask a question. What a nice rhyme. Good. So people, this is where we end our class. We are going to continue with a different topic, maybe algebraic expressions. We go deep into that and we follow. I want to build all the basics for you, the beginners, before we can all start doing what math. Take this seriously. Because once you understand this, I bet you, your math is going to be very, very good and very, very sharp. So thank you very much for joining the class. This is the end of Integer.